Okay, this is the second part of the review for the final. The second main area that we covered was the gas laws. And the gas laws included gas stoichiometry. And when we talk about the gas laws, we're talking about a gas, and we find out that it changes greatly with temperature, pressure, the volume changes greatly, and with the number of molecules. So we have a number of gas laws. Because of the nature of this test, you are not going to be required to memorize those. You can have them on a piece of paper. It's an open note, open book test. Your job will be to figure out what it is that you need from them. When it comes to gas laws, we have pressure, volume, temperature, number of moles. These are our four main qualities or characteristics. Let me see if I can get a better pen here. They, all of our gas laws are going to work with those. You may remember the temperature always has to be in Kelvin, with one exception. That would be if we were doing Dalton's law and we're working with vapor pressure, then we usually measure vapor pressure using Celsius. But normally we need an absolute pressure temperature to be able to measure due to the gas laws. And that's because of the nature of the gas laws. So we have a bunch of different gas laws. We started with Boyle's law. Boyle's law is P1V1 equals P2V2. Charles' law is V1 over T1 is V2 over T2. And Dalton, or Gay-Lussac's law, I should say, is very similar. It's P1 over T1 equals P2 over T2. We have the combined gas law. And it is P1V1 over T1 is P2V2 over T2. And let me just mention, I'm not going to write it down there, but anything, if we don't have N or T here, those are constant. N and P are constant. P or V and N are constant. Here the number of moles is constant. N meaning the number of moles. And finally we have what's called the ideal gas law, which you would guys know as Pivnert. And Pivnert is our overarching law. It allows us to find one if we don't know the others, if we know the others. R here is 8.31 kilopascals, liters, moles, Kelvin. And those are the gas laws. With this one, it's important to mention that we had something called STP, which stands for standard temperature and pressure. Standard temperature is 273 Kelvin, or 0 Celsius, and pressure would be 101.3 kilopascals. So if we talk about STP, and that's very common on one of these. We have another gas law called Dalton's law of partial pressures, and that was the pressure of a gas total is equal to all the partial pressures. And where that got used the most was when we were collecting a gas over water, because when we collect a gas over water, we're interested in what the water temperature is, because that gives off more vapor. And so we had something with Dalton's law, which was P, the pressure of the wet gas is the pressure of the dry gas, which was the pressure of the atmosphere, plus the pressure of the water vapor. And this would have to be given to you either on a chart or given to you in the problem itself, and you could work that out. And then we had something called Avogadro's principle. And Avogadro's principle is really important. Avogadro's principle says that equal volumes of different gases have the same number of moles. In other words, it doesn't matter what gas we're dealing with. Gas molecules are so tiny and act in such a way that we can ignore which gas it is that we're working with. And Avogadro's principle technically looks like this. V1 over N1 is V2 over N2. Change the amount of moles, and you'll change the amount of volume. but it doesn't matter what gas we are. But here's the main point of Avogadro's principle, and that is that 1 mole of any gas equals 22.4 liters at STP. Okay, and that gets used in our gas laws. In our gas stoichiometry. So your job on any problem is to figure out, first of all, what it is that we're working with. The stoichiometry problem will be obvious, but if it's a gas law problem, you have to start looking for things. If I only give you pressure and volume, it's a Boyle's law problem. If you just have volume and temperature, it's Charles. Pressure and temperature, Gay-Lussac's. If I give you all three, or if you ever see STP, assume it's a combined gas law problem. One where we're asking about the number of moles, or where you know the number of moles, where that's given, that's almost always a Pivnert problem. Dalton's law usually comes out when we're doing a lab, because that's where it would happen the most, and the problem will say you collected a gas over water, and then you know you have to start adjusting for it. I'm not going to do an example of each problem. I will be able to help. If you have other questions than what we have, but let's just throw out a couple of quick problems. I'll do 3 or 4. So let's say you were told you have a gas at 23 degrees Celsius and the pressure is 80 kilopascals. What is the pressure if we go to the temperature rises to 100 degrees Celsius? Well, look at what we've got. We've been told about temperature. T1 is 23 Celsius. Immediately add 273. This would be 296 Kelvin. P1 is 80 kilopascals. T2 is 100 degrees Celsius, which would be 373 Kelvin, and P2 then is what we're looking for. And since no other information, this is a Gay-Lussac's law, but you don't need to know that, you just need to know the formula for it. And so we would do 80 over 296 is P2 over 373, cross multiply 80 times 373 Kelvin divided by 296 Kelvin, and that would give you P2. And work that out and you'll have your answer. Now, I could do the same thing for each one of the other ones. I'm not going to, but let's do one where we said that we've got a gas, this very typical, occupies 50 milliliters at 26 degrees Celsius. Let's make it 126 degrees Celsius and 99.2 kilopascals. What is the volume at STP? Again, the minute you see STP, you're thinking combined gas law. P1 is 99.2. T1 is 126, but add 273, that's going to be 399 Kelvin. And T1V1 is 50 milliliters. And over here, we're looking for V2. P1 is 101.3, and T1 is 273 Kelvin. So setting it up, we're going to have 50 times 99.2 over 399 Kelvin is equal to 101.3 times 273 Kelvin. 273 Kelvin on the bottom, I apologize, and V2 on the top. And if we multiply both sides through by 273 over 101.3, we will get to our answer. We do that on both sides here, and that'll cancel out. Or you can cross multiply if you would rather, right? And that would be our answer when we multiply it out. A Pivnert problem is probably going to look more like where they're probably asking you for the number of moles. So you go and look at some